Romex cable, also known as NM cable, is permitted above a suspended ceiling in commercial buildings. The code reference is 2023 NEC 334.10b2. There are conditions that must be met. Firstly, the cable must be installed in accordance with the manufacturer's instructions. Secondly, the cable must be protected from physical damage. Thirdly, the cable must not be subject to excessive heat or moisture. In general, Romex cable is not allowed in commercial buildings for several reasons. Firstly, it does not meet fire resistance requirements. Romex cable is not fire resistant and does not meet the fire safety requirements of commercial buildings. Secondly, it is not suitable for exposed locations. Romex cable is not designed for exposed locations and can be easily damaged by impact or abrasion. Thirdly, it is not permitted in areas requiring conduit. In many commercial buildings, conduit is required for electrical wiring, and Romex cable cannot be used in these areas. There are exceptions, however. Romex cable may be allowed in certain commercial buildings, such as small offices or retail stores, where the fire safety requirements are less stringent. Also, Romex cable may be allowed in concealed locations, such as inside walls or ceilings, where it is not exposed to physical damage. Specific cities may have additional regulations regarding the use of Romex cable in commercial buildings. It is always best to consult with local building codes and electrical inspectors to determine the specific requirements for your location. NEC Section 334.10 covers uses permitted for non-metallic sheath cable types NM, NMC, and NMS. In dwelling units, uses permitted include for both exposed and concealed work in normally dry locations. Also, uses permitted include where cables are run in air voids behind thermal insulation. The insulation must be that is fiberglass, mineral wool, or cellulose insulation. Uses not permitted for types NM, NMC, and NMS cables include firstly, service entrance cables. Secondly, in commercial garages and aircraft hangars. Thirdly, in theaters and similar locations, except as provided in Article 518. Fourthly, in motion picture studios. Fifthly, in storage battery rooms. Sixthly, in hoistways. Seventhly, embedded in poured concrete, cement, or aggregate. Eighthly, in any hazardous locations except as specifically permitted by other articles in this code. Ninthly, where exposed to corrosive fumes or vapors. And tenthly, when run or fished in thermal insulation. Type NM cable is specifically not permitted under the following conditions. Firstly, in any dwelling or structure not specifically permitted in 334.10 AON, meaning 1 and 2 family dwellings and associated structures. Secondly, in types 3, 4, and 5 construction. It is important to understand the construction types as defined by the International Building Code, or IBC. Type 1 construction is that in which the building elements are of non-combustible materials such as concrete, steel, or masonry. Type 2 construction is similar to Type 1 construction but with less stringent fire resistance requirements. Type 3 construction is that in which the exterior walls are of non-combustible materials and the interior building elements are of any material permitted by the code. Type 4 construction is that in which the exterior walls are of non-combustible materials and the interior building elements are of solid or laminated wood without concealed spaces. Type 5 construction is that in which the building elements are of any material permitted by the code. The specific requirements for each type of construction can vary depending on the local building code. Local amendments and interpretations of the NEC can further restrict or clarify the use of Romex cable. Always consult with the local authority having jurisdiction, or OJ, for the most accurate and up-to-date information. Proper installation is crucial for the safety and longevity of any electrical system. Always follow the manufacturer's instructions and any applicable codes or standards. When working with electricity, safety should always be the top priority. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. NEC Article 334 provides detailed requirements for installing NM cable, including support, protection against physical damage, and ampacity. Understanding these requirements is essential for ensuring a safe and compliant installation. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Changes in the code can affect the types of wiring methods that are permitted in different applications. Factors influencing the choice of wiring method include cost, ease of installation, environmental conditions, and the type of occupancy. It is important to consider all of these factors when selecting the appropriate wiring method for a particular application. Other wiring methods commonly used in commercial buildings include electrical metallic tubing, or rigid metal conduit, or RMC, and cable tray. Each of these wiring methods has its own advantages and disadvantages, depending on the application. When selecting a wiring method, it is important to consider the potential for future expansion or modification of the electrical system. It may be more cost-effective to install a more robust wiring method initially, even if it is not strictly required by the code. Proper grounding is essential for the safety of any electrical system. All metallic wiring methods must be properly grounded to provide a path for fault current to return to the source. Grounding requirements are covered in Article 250 of the NEC. Overcurrent protection, such as circuit breakers and fuses, is essential for protecting electrical wiring from overload and short circuits. Overcurrent protection devices must be sized appropriately for the ampacity of the wiring. The NEC provides tables for determining the ampacity of different types of conductors. Voltage drop can be a significant problem in long electrical circuits. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. When installing electrical wiring in commercial buildings, it is important to coordinate with other trades, such as plumbers and HVAC technicians. This can help to avoid conflicts and ensure that the electrical system is installed in a safe and efficient manner. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safe and reliable operation. Electrical systems should be inspected periodically by a qualified electrician to identify and correct any potential problems. The use of Romex cable in commercial buildings is a complex issue that depends on a variety of factors, including the type of construction, the occupancy, and the local building codes. It is important to carefully consider all of these factors before deciding whether or not to use Romex cable in a particular application. Always consult with a qualified electrician or electrical engineer to ensure that the electrical system is installed in accordance with all applicable codes and standards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified professional before making any decisions about electrical wiring. Understanding the specific requirements for your location is critical, as local amendments to the NEC can significantly impact the allowable uses of NM cable. For example, some jurisdictions may have stricter fire resistance requirements than those outlined in the NEC, further limiting the use of NM cable in commercial buildings. Always check with the local authority having jurisdiction to determine the specific requirements for your project. In addition to fire resistance, other factors to consider when selecting a wiring method for a commercial building include the potential for exposure to moisture, chemicals, or physical damage. If the wiring is likely to be exposed to any of these hazards, a more robust wiring method, such as EMT or RMC, may be more appropriate than NM cable. The type of occupancy also plays a significant role in determining the allowable wiring methods. For example, healthcare facilities and assembly occupancies often have more stringent requirements than office buildings or retail stores. Be sure to consult the applicable codes and standards for the specific type of occupancy before selecting a wiring method. Proper labeling of electrical panels and circuits is essential for safety and maintenance. All circuits should be clearly labeled to indicate the loads they serve. This will help to prevent accidental disconnections and make it easier to troubleshoot problems. Electrical drawings should be kept up to date to reflect any changes or modifications to the electrical system. This will help to ensure that the electrical system is properly documented and that future work can be performed safely and efficiently. Training is essential for anyone who works on electrical systems. All electrical workers should be properly trained in the safe and efficient installation, maintenance, and repair of electrical equipment. Continuing education is also important to stay up to date with the latest codes and standards. When working with electrical systems, always use the proper personal protective equipment, or PP. This includes items such as safety glasses, gloves, and insulated tools. Never work on energized electrical equipment unless it is absolutely necessary. If you must work on energized equipment, be sure to follow all applicable safety procedures and use the proper PPE. Lockout/tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair. Always follow proper lockout/tagout procedures before working on any electrical equipment. Regular safety audits can help to identify and correct potential hazards in the workplace. Safety audits should be conducted by a qualified safety professional. A comprehensive safety program is essential for creating a safe and healthy work environment. The safety program should include elements such as training, hazard communication, and emergency response. Collaboration between electrical engineers, electricians, and building owners is essential for ensuring the safe and efficient design, installation, and operation of electrical systems. Open communication and a willingness to work together can help to prevent problems and ensure that the electrical system meets the needs of the building and its occupants. The principles of electrical safety and code compliance are applicable to all types of electrical systems, from small residential installations to large commercial and industrial facilities. A thorough understanding of these principles is essential for anyone who works with electricity. The NEC is a living document that is constantly evolving to reflect changes in technology and industry practices. Staying up to date with the latest edition of the NEC is essential for ensuring that electrical systems are installed and maintained in accordance with the latest safety standards. The use of technology can help to improve the efficiency and accuracy of electrical design and installation. For example, computer-aided design, or CAD, software can be used to create detailed electrical drawings. Building information modeling, or BIM, can be used to coordinate electrical systems with other building systems. The increasing use of renewable energy sources, such as solar and wind power, is creating new challenges and opportunities for electrical engineers and electricians. New codes and standards are being developed to address the unique requirements of these systems. Smart grids are transforming the way electricity is generated, transmitted, and distributed. These grids use advanced technologies to improve efficiency, reliability, and security. The growth of electric vehicles is creating new demands on the electrical grid. New charging infrastructure is needed to support the widespread adoption of electric vehicles. The increasing use of electricity is placing a greater emphasis on energy efficiency. New technologies and practices are being developed to reduce energy consumption and improve the efficiency of electrical systems. The electrical industry is constantly evolving to meet the changing needs of society. A commitment to innovation and continuous learning is essential for success in this dynamic field. The safety of the public and the environment is paramount in all aspects of the electrical industry. Electrical engineers and electricians have a responsibility to design, install, and maintain electrical systems in a safe and environmentally responsible manner. In summary, when determining the suitability of Romex NM cable in commercial buildings, consider the specific construction type, occupancy requirements, local amendments to the NEC, potential environmental hazards, and the need for future expansion or modification of the electrical system. Consulting with qualified professionals and adhering to all applicable codes and standards is crucial for ensuring a safe and compliant installation.